Welcome, everybody. Oops, I had the wrong slide up before we started. Boy, it's almost like you don't do these every day and then you forget which buttons to click when it is time. However, back by popular demand for this Lunch and Learn, Andrea Henderson, who is our Domo Manager of Data Pipeline Architecture. So excited for her to be joining us once again. And back by popular demand because her last session got so many comments and so much engagement that I was excited to ask her to fill in for today's Tuesday Lunch and Learn. Andrea, thank you so much for being here. Before we get to the main event, which we'll be talking all things data pipeline today, I do want to briefly mention a few things that's gone on over the last couple of weeks. We did launch our 2023 Domo Community Ovation Awards. If you have not swung over to the Domo Community Ovation Awards page and nominated someone either close to you or, don't be shy, nominate yourself. Click the QR code. You can nominate anyone, including yourself, for the Positive Impact Award, the Most Novel Application Award, the Best Domo Everywhere Application, the Executive of the Year. This is your chance to scan that QR code and get that nomination in. These are the very first one-of-a-kind 2023 Domo Community Ovation Awards. We're even, Andrea, I've been told, going to be doing a special awards ceremony and a virtual chef event for some of the folks that are being nominated and awarded into categories. It's going to be awesome. We're really excited. So if you haven't done that yet, rewind just a little bit, just a hair, scan that QR code and nominate either yourself or your friends. Also, if you haven't been paying attention, we launched our very first community meetup. We had over 300 people join us, over 600 people registered. We're so excited to continue these. We'll be doing another one in March, details coming soon. But if you'd like to watch the recording, you could scan that QR code. It will ship you right back into YouTube so you can see the recording of our hour-long community meetup with our good friends Ben Shine, Mark Mon, and Elliot Leonard talking all things Domo. Woo, that was a lot. Now I get to turn it over to Andrea, who is my dear friend over in Data Pipeline. She's got a fantastic session where we're going to talk about methods and tooling on the data pipeline architecture, which I'm so excited. There's tons of transformation and ingest stuff that she's going to be discussing. I should just get out of the way and let the star of the show talk. Andrea, thank you so much for being here. Appreciate you and excited to see what you have for us.
Thanks, Eddie. Happy to be back. Always excited to geek out about data pipelines. So let me just find my correct window here. All right, perfect. So today I want to talk a little bit about how to think about data pipelines in Domo from a tooling perspective, from a method perspective, and basically really go into how to think about the different options that you have in Domo and how to assemble the best data pipeline that you can assemble in Domo. Kicking it off, I want to talk a little bit about what the different parts are that I would consider part of a data pipeline. What goes into this construction of a data pipeline? So when I'm talking data pipelines in Domo, what I'm thinking about is a few different things. I'm thinking about ingest, how you get that data into Domo. I'm thinking about data accumulation and storage, how that data lives within the platform and how it's updated in place. And then I'm thinking about transformation using some of our amazing Domo transformation tools. So when I'm talking ingest, I'm thinking things like our huge connector library. I think we're over 500 now. Workbench, using file uploads, using things like the Domo CLI and even our APIs in order to ingest data. Speaking about accumulation, this is where I'm thinking more methodically in the method realm. I'm thinking about where we have methods like replace, append, upsert, and partition available for data storage and accumulation. And then I'm also thinking in the realm of transportation. I'm thinking in the realm of transformation. I'm thinking Magic ETL, our SQL data flows, Adrenaline data flows, even Dataset Views play a part in this transformation. So I really want to talk about what we have available in all these realms, how they play together, what you want to use when in order to assemble the best pipeline. In my mind, when I'm thinking about a data pipeline, I want to create or build a pipeline that is both robust and error tolerant, something that is self-healing, and then is also efficient, runs in an efficient amount of time, doesn't reprocess extra data. So when I'm going through and building out a new pipeline, or when I'm assessing a pipeline that someone else has built, what I'm looking for is kind of these things. It's kind of like a checklist that I go over. I want to make sure that the pipeline will handle system outages, that any manual processes are minimized or eliminated altogether. I want my pipeline to run hands off regardless of what happens to me. Um, I want to make sure that in cases where something like the pipeline is run twice, or pipeline doesn't run for a day and needs to catch up, that data isn't corrupted in the pipeline. I also want to make sure that I am designing or architecting my solution in a way that minimizes duplication of data across different data sets. And then other items, I want to think about how the time to run happens within the pipeline. I don't want it to grow linearly as I get more history in the pipeline. I want to make sure that if there are metrics that can be rendered at the runtime of a card or a data set, I want those to be unmaterialized if possible. Um, and basically, I just want to make sure that there's monitoring support in place for the pipeline. Um, so a story that my boss, Ben Shine, tells often is this story about a man who is building a porch, and he has hold of a saw, and he's hammering in a nail with the saw, and his hand's getting all bloody, and it's not very effective. And someone comes along and says, "Why are you hammering in the nail, with that saw? That's not the right tool for that." And he says, "Oh, well, the saw worked so well for cutting up those boards and whatever." Um, and so I figured I could use it in order to hammer in my nails too. And the point of the story really is, when we are building out things in Domo, we should make sure that we're not trying to hammer something with a saw, or that we are not seeing everything within our pipeline as a nail and using a hammer in order to hammer in those nails. There are a lot of different tasks that need to be done in your pipeline, and using the right tool for the right task will really get you the best, most robust, most efficient pipeline possible. So moving into some of the detail here, I want to talk first about ingest methods. So how you're getting that data into Domo, what is available to you, what you might want to use, and when. So rather than breaking this out by ingest method, I'm going to break it out by activity that you might be doing, or use case that your data might have. I'm leveraging some of my teenagers' lingo here with this whole POV thing. So bear with me as I attempt to be cool. Okay, so let's say your data is in the cloud. How are you going to get that data into Domo? You have a lot of options within Domo to do that. You have our extensive library of cloud connectors, which includes both cloud connectors, database connectors, anything where the data lives in the cloud. We have a huge library to bring that in. We also have connectors to bring in data that may not have its own specific cloud connector. You can use things like the email connector. You can use our file connectors. You can use our no-code JSON connector. There's a lot of different options for you to get that data into Domo. A lot of people will start to look at our extensive library of connectors, and they'll say, "Oh, this little niche system that I have doesn't have a connector, so I don't know how to get that data into Domo." Um, in those use cases, I would urge you to look at things like the JSON no-code connector, or even to look at and see, does that system have the ability to automatically generate a file or email me a file or something like that. Domo has really robust and flexible connectors to help you handle those types of use cases. You also have the ability to use APIs. So if your system has APIs available that you can use to extract data, Domo has the ability for you to use those and bring that data into the platform. And finally, there are also cases in which you just want to federate to your cloud data. We have a number of federated connectors, and I'll talk about that a little more in a minute. So let's say your data is on-prem. You have an old school database, your company owns the hardware, your data is on-prem. good news, a lot of different options for you there too. We have our Workbench utility, which a lot of our customers leverage very heavily. I'm going to be honest, it's not our sexiest tool. No offense to the Workbench team, but it does the job solidly, and has a lot of the accumulation methods available in it that may not be available in other connectors. So Workbench, a solid possibility. We also have database connectors that you can use to bring in data from on-prem databases. You can also do things like export CSV files from your database or unload CSV files and use our file connectors. You can use the Domo CLI, which is just a lightweight Java utility that acts as a wrapper for some of Domo's APIs. So that can be built into a pipeline process, or you can federate to uh, on-premise data with our federated adapters. Another option, so some customers say, well, my data needs to stay where it is. Our team doesn't want us duplicating data in other systems. Our team wants our data not leaving our systems for whatever reason. Great, we have options for you too. We have a pretty extensive library of federated connectors that you can use in order to get at that data where it lives. The data will stay at rest. Domo will only access it and use it to render your cards and dashboards. We also have an offering called Cloud Amplifier, which is almost like a federated plus at this point, in which you can use something like Snowflake as basically an extension of Domo, or use Domo as basically an extension of Snowflake. So that's a much deeper topic, and probably something to do a whole session on at some point. Finally, a lot of customers will say, I need really fast refresh rates for my data. I need my data faster than this 15-minute limit set on the connectors or whatever. Again, a lot of options there within Domo. You can use federated or cloud amplifier. You can also use the Domo CLI to build really high velocity pipelines where you are bringing in data into your data sets very rapidly, in just minutes. You can also set up things with our APIs. So moving on from this concept of ingest, in which there are a number of different tools to use for different purposes, depending on um, what your data needs are, where your storage is, what your latency needs are. Moving on from that, let's talk a little bit about storage or data accumulation. Um, I kind of lump these together because the methods that I think about in this realm kind of span those two concepts. Just to make sure that we fully understand what these concepts are. So when I'm thinking replace, I'm talking about taking an incoming data set and replacing the entire current data set as it exists in Domo with that data. When I'm talking append, I'm thinking bringing in a data set or a set of records and just appending it onto the current data. So the current data is still there, the new data is just appended on. When I'm talking Upsert, I'm thinking at a row unique identifier level. So I'm looking at rows that are coming into Domo. I'm looking at a unique identifier that exists on the row level, and I am updating or appending data to the data set based upon that unique identifier. And then partitioning, a little bit similar to Upsert, but instead operates on groups of rows, and you either replace or add these groups of rows based on the group identifier. So the last lunch and learn I did here, I was nerding out about partitioning. Partitioning is my entire personality, so I won't go into that in too much detail here, but I do want to talk about when you would want to think about using these different ingest or accumulation strategies. So thinking about replace, I tried to create some nice diagrams here to help visualize what is actually happening in these cases. So when you might want to think about just completely replacing a data set upon ingest, it's cases when your data are small enough that the time to replace is just immaterial. You have a 10,000 row data set. It doesn't make a lot of sense to build out a partition scheme or anything like that for that data because you can just replace it in a matter of seconds within Domo. Things like dimension tables, pretty small transaction tables. It's very simple because that means that whatever data is coming in just replaces what existed there. Any updates to the rows that are represented with the new data are just wholesale replaced into your existing data. Um, this method is available everywhere in Domo. It's kind of the default in connectors, in Workbench. It was previously the default in Magic, still is the default in Magic. It's how SQL data flows function. So you run data through a SQL data flow, whatever your output is going to replace your entire current output and adrenaline data flows. So this is kind of the base level replace concept within Domo. The concept of append is similar, but instead of replacing what exists within the data set, it is just added onto the data set. Cases in which you might want to use this is if the data that you're ingesting are too large to update everything or do a full replace in a timely fashion. You might want to think about this when you're just doing point in time snapshots. There are honestly very limited use cases for this because it creates a pretty brittle pipeline. If you think about when I was talking about robustness and efficiency a little bit ago, this would create a non-robust pipeline. If your data set if your input data connector or whatever was to run multiple times in a day, you would just end up with duplicate data, multiple data being added. Or if you had a case in which your connector didn't run for 2 days, you've just missed that data and it's missing from your data set. So this concept of append, though, is available in connectors, in Workbench, which you can set it up that way. It's also now available in Magic in a beta version. Again, I would almost always point you to partitioning in Magic, though, over this concept of append. Moving on to maybe a little bit more sophisticated is the concept of Upsert, in which these incoming rows replace or are added to the current rows based on a row level identifier. So the cases in which you might want to use this concept are cases in which the data is too large to do a full replace. So like if you do frequent updates to historical data, if your updates are spread amongst a large amount of history, but are just kind of like ones and twos throughout your data set. And or they're dimensions that are frequently updated, transactional tables where the transactions are modified after they're written. So basically cases in which you want to update your data, but the way that the data is structured doesn't lend itself to being partitioned. So this is less efficient than partitioning. It's still more efficient than doing, say, a full replace or creating a recursive data flow with this pattern. So this is available now in some connectors. It's available through Workbench, and it is coming soon in Magic. It is not yet available to be tested in Magic. It's not part of the current partitions beta, but it is coming. So this will be available to you soon. And then finally, this concept of partitioning. So this is where the groups of rows that are coming in are either added or replace existing groups of rows. And this is designated by a partition name or tag or key, whatever you want to call it there. This is a excellent pattern to use as far as creating really robust and efficient pipelines because you're only ever touching the segments of the data that need to be updated or need to be appended to. You don't have to reprocess huge groups of rows. This is great if you make frequent updates to kind of recent historical data. So, for example, if you are bringing in data from Facebook and it has a 7-day curing period, and so during those 7 days, you're updating it with a rolling 7 days continuously, having a partitioned method for that is for that accumulation is ideal. So where is this available? It is available in some connectors, it's available through Workbench, and it's now in beta through Magic. If you're interested in that, I would point you back to the last stream that I did where I kind of dive deep on partitioning in Magic, and you're also welcome to reach out to me about it. And just a nice summary table here. I stole this from my colleague Dan, who you probably heard from in a previous session. But basically, a nice, neat summary of where these different accumulation methods are available. I would point you to this bottom couple here, in which you can see, SQL Dataflows only have replace available. Magic has replace append. Uh, a unfilled in green for partition because it is in beta, and an unfilled in orange for Upsert because it is kind of in an early alpha at this point. So we've talked ingest, we've talked data storage and accumulation. Let's talk about, to me, what is the most fun, which is in the transformation layer, how you're thinking about transformation within Domo. Once the data is here, once it's stored, once you have that portion of your pipeline running smoothly, how do you think about transformation and data prep? And what tools do you want to use for which types of transformation? I cannot tell you how many people I see using like MySQL data flows or Redshift data flows for literally everything. Which is so inefficient. Those things have their place, and we'll talk about it in a minute. But for the most part, it will take multiple different tools or different types of tools in order to get your data prepared in the most efficient way possible. Um, so if you're one of the crowd of, you can have MySQL data flows when you pry them from my cold dead hands, like I feel you. I previously was of that group. I write SQL as efficiently as I think. So the idea of using a different tool to do data prep feels really arduous to me. But some of the other options are just so much more efficient that it only makes sense to look into them at least. Um, so the first thing I want to talk about is Views Explorer or Dataset Views. This is a non-materialized tool that allows you to interact with your data and to create transforms on top of it that are not materialized, and they only occur at the time that either the data set is loaded or the card that is built off of the data set is rendered. So this is great for kind of basic data cleaning, filtering, row by row calculations, doing some simple joins without really complex logic. And it's great to use with smaller data sets when you need to do some data prep for them. It's also really good for data exploration and exporting. So we have a lot of customers who will say, I just want to get my data out and look at it in Excel. And that's because that's how we were all trained, right? We all learned Excel. This is pretty Excel like in how it behaves, and I've actually found myself using it in a lot of those cases where I have that old urge to pull my data out into Excel. So using it to do some exploration is great. We also have some people who use it almost in a data modeling capacity, in which they will define their metrics or they will define their calculations in a dataset view that everybody can reference when they're building out their own data sets. Um, so if you can do your transformations in a dataset view and it renders in a time that is acceptable to you at the card level, I would recommend going to dataset views first. Um, it will really cut down on your end-to-end pipeline time if you can leverage it. Um, I will not, I will preface this by saying this is unofficial. This is just my own experience. When you get up into the hundreds of millions of rows with data set views, depending on what you're doing, you may find the performance start to degrade. So when you're getting into really they're complex joins, really complex calculations. You have really wide tables. You have tables that are, in excess of 500 million rows or so. You might start to see that you need to use a different tool for your data. Moving on to Magic. So this is my favorite. When I started at Domo, we were in Magic 1. I refused to use it. I would use it only if I had to. Um, Moving into this new world of Magic 2, I think it went into GA about a year ago. Um, it is such a more efficient tool. The processing is so much more predictable, and it's so robust that I do everything in Magic these days. And I would recommend that you use it for anything that you can't use a dataset view for, or anything in which you want the output to be materialized. So any data cleaning, complex joins, calculations, data enrichment, like the vast majority of things that you need to do in Domo, I would point you to Magic. Um, there's not a lot else to say there. I will show you an interesting design pattern in a few moments that leverages Magic that you might find useful. But overall, if you can do it in Magic, do it there. And if you don't think you can do it in Magic because there's no apples to apples SQL statement to tile available to you, I would challenge you a little bit to think a little bit outside the box, to refactor things in your mind. Um, I've been toying with a concept of doing a live stream in which we talk about converting SQL data flows to Magic data flows. If that's of interest to you, let me know. Maybe we'll have Eddie get it on the schedule. But I would challenge you to think and refactor if you think that you cannot do your data flow in Magic. To date, I have not found a data flow I could not replicate in Magic. So speaking of SQL data flows, they are available, MySQL and Redshift. I would use them very sparingly and only when I know I needed specific functions or calculations that were not available in Magic. There are cases in which you might want to create a function for brevity's sake. I have often found that I can recreate the same logic or the same result as a function in Magic, but I understand that sometimes the elegance of writing the function in Magic or in SQL is, outweighs, in which case, fine, go ahead and use the SQL. Sometimes it is much more elegant to do non-equijoins in SQL. So, I don't judge you if you use SQL for those things. But a lot of customers really find that the variability in load and write back times in the SQL data flows just really makes them an unattractive option in comparison with Magic, and they'll often, find a way to be able to use Magic. Finally, adrenaline data flows. This is the biggest example I see of people using a saw to hammer a nail. Adrenaline data flows are massively powerful. They run on directly on our adrenaline engine. They can handle enormous data, but they are really intended for kind of a narrow use case. Usually people will get a hold of them, they'll see how efficient they are for some use cases, and they'll try to use them for everything, and they'll find they have bad performance. They get data that times out. They it's not as efficient as they thought it would be. So adrenaline data flows they really, really shine in data reduction use cases. So if your first step in your data processing is to take a multi-billion row table and aggregate it or filter it massively, an adrenaline data flow is perfect for that use case. However, if your use case is you have a 500 million row table and you need to join it to a 50 million row table, and you need to do a bunch of calculations and a bunch of other joins, and you're going to output 500 million rows, adrenaline data flows is probably not where you want to do that. You're not going to find a lot of utility doing it there. Um, so having gone through all of those things, a couple of design patterns that I feel like I've talked about them a lot of times. I know our user base is huge though, and there's new people coming in and out all the time. So I just want to talk about a couple of design patterns that you might want to think about when you're designing your pipelines. One of my favorite design patterns is this concept of using dataset views as an input to a Magic data flow, particularly in the realm of filtering. So you can use a dataset view in order to perform some filtering on your data prior to Magic and just making that dataset view an input to Magic, which means that in Magic, you're only ingesting a subset of the data that exists in your dataset, and your whole pipeline will run much faster end to end that way. There have been many times in which I have redesigned a pipeline and been able to pinpoint where they were doing some filtering kind of as one of their first few steps in the pipeline. And we were able to reduce runtimes, from 10 plus hours to minutes because we were performing those functions in a dataset view. So thinking about how you can incorporate dataset views into Magic can really help the efficiency of your pipelines. The other thing that I wanted to talk about a little bit is more from a card perspective. However, data pipelines really encompass anything from the point of ingest to visualization and to optimizing your data for that visualization. So one design pattern to think about is in how you're designing your dashboards. A lot of customers will build out a really big data set that has everything in it at a granular level, at a transaction level, and then they'll build the dashboard on it, and their dashboard is really slow, and they're disillusioned and they quit their job. Just kidding, they don't do that. A way to get around that, or one of the ways to think about that, is to take your enormous data set and using magic or adrenaline, create a aggregation of that data set on which you build those top level cards on your dashboard. Those cards that'll answer the first, 80% of someone's questions. And then on your dashboard, when you build your drill paths, build those drill paths to drill down to the larger data set or to even drill to a federated data set. That's a design pattern that has come about more and more. People are using it more and more, in which they will bring in an aggregation of data to Domo, use Domo basically as a high-speed cache, in which case their dashboard will load really snappy on that aggregate data, and then they build their drill downs on their federated data sets. All right, Eddie, that is kind of what I had to talk about. Do we have any questions about data pipelines? Anything I talked about?
Yeah, we've got quite a bit of quite a bit of folks. I was able to kind of hold marks up here while you were finishing up there. Specifically about Magic ETL, he's mentions here that he was able to eliminate all of his Redshift data flows with Magic ETL. They run a lot faster, easier to maintain. Can't recommend Magic ETL enough.
Bravo, Mark.
Another plus one. I'm not even going to attempt it.
Alexi.
But our friend Alexi, there you go, agrees with Mark there. Mark says, a question often asked in Dojo, if there is a way to quickly convert an SQL data flow to a Magic ETL data flow, since it is an apples to apples conversion, having you demonstrate it would be helpful.
Yeah.
Is there and honestly, there's probably a lot. This is probably, we could probably dive pretty deep here and take a lot more time to go into that. So
Yeah, Eddie, I think we should do a follow-up session at some point, maybe the next one I do,
yeah,
in which we can dive deep on tips and tricks for converting SQL to Magic.
right.
In addition to that, I do want to mention that there is a SQL tile in development for Magic, which, I would caution this concept of just taking SQL and dumping it into Magic, but it will give you an opportunity to kind of, cut and paste more of your logic.
I love that. Another one. Thank you, Andrea, for presenting. Interesting use case, and our friend Daniel, who's been in the community recently and signed up through the session through the community, which we thank him for that. Andrea, your presentations are always great. Thank you. Told you, we back by popular demand. Lots of folks always love when we have Andrea on, and super excited we were able to do it again. Andrea, let's do that. Let's put that on the calendar for next time. Let's do some more deeper dives into this. We obviously have some captive audience, so just be on the lookout for the next live stream. And we'll be more than happy to share some of those examples as we move forward in these lunch and learns. So if you're not already signed up, you can find us on the Dojo events page, as well as YouTube. Anytime we go live, there are sessions that we also do then push out to Facebook and Twitter and LinkedIn. But YouTube and community are the standards of when you can find us on Tuesdays and Thursdays every week. Andrea, thanks again for joining us. Always appreciate it.
Thanks, Eddie.
This session is so good. All right. Well, see everybody later. Thank you for joining us. We're back on Thursday for the next Lunch and Learn. Again, you can find us on all social media channels. And don't forget to keep collaborating and communicating on the Dojo. Appreciate everybody. Have a great day.
Thanks, everyone.